Hello everybody, this is Jun Li from Sun Yat-sen University. It's my great honor to have this opportunity to share our recent work, Distributed Fusion of Heterogeneous Remote Sensing and Social Media Data, recent development in the Proceedings of the H3, thanks to the guest editors and to this webinar. Next page. As just mentioned by our leading guest editor, Professor Jun Li, right now for most of the Earth observation applications with one type of data is almost impossible to accomplish the application. So in general, we need to use multiple types of different kinds of data. In this talk, we are going to focus on remote sensing and social media data. We have a growing demand for rapid diffusion, especially in the area of emergency response. Second advantage of remote sensing data, we have the wide range from the spatial range observation. And then for the social media, but it has the limitation, the remote sensing data with the limitation of the temporal resolution, and also sometimes because of the conditions. For instance, the weather condition, wind, rain, cloud, these issues, we do not have remote sensing data. For the social media data, we have a lot of different kinds of social media, for example, Twitter, and in China we have Weibo. This kind of data, they have a very timing generation. So from this viewpoint, we have a good protection to use this remote sensing and social media data for many applications. Next page. However, the fusion of remote sensing and social media data, because of the different structure and different sources, the fusion are very difficult and complicated, and with no efficiency. So in order to meet the demand for fast real-time or real-time application, we needed to use high-performance computing techniques, such as, for example, we have two kinds. One is parallel computing, the other one is distributed computing. Both of them have advantages and also has limitations. Next page. Thanks. So as we can see here from the table, we have we have a comparison between these parallel and distributed computing technologies. For example, we have MPI, OpenMP, CUDA, and GEE, Google Earth Engine. We have advantages and the limitations. For example, for MPI, the advantages is time of taking large-scale data intensive problems. However, its limitations, the speed up or the computation cost is very heavy. It's a problem. And why for OpenMP? The advantage is that we can be thread can be shared, and the parallelization can be done within a single computer, but it is very difficult to resolve the large-scale problem. It's also the same phenomenon we can observe for CUDA and Google Engine. Google Engine GEE is a recent, very fast development engine, and a lot of research have been done there. It has a lot of advantages. It also has some limitations. For example, less security is a limitation, and the internet required. Next page. So in this work, or in this review, we combine the advantage of parallel and distributed, namely MPI and OpenMP, to implement two levels of parallelism. As we can see from here, from the figure, we can see we use this fine-grained parallelism with computing nodes, and cosecant parallelism across nodes for the fusion model to fuse remote sensing and social media data. Next page. Here we are going to show one case study. The case study is with fusion remote sensing data is 9sat 8 remote sensing data collected by 9sat 8 and treated data. The 9sat image we can see in the background in the back, and then the treated the green points. We also have the ground truth, the UFE, and we also have the historic distribution of the flood area. This data is the study area is in the collected from the 2013 near Bolivia. Next page. Thanks. This is the experiment environment, because here with the data we only have around 2,000 to a bit more than 2,000 treated data, so the computation is not so heavy, but it is still quite challenging for the problem. And for next page, thanks. So from here we can see we have a quantitative evaluation from the time aspect, the computational aspect, the quantitative evaluation from the accuracy. If anyone interested can look into the paper. Here we focus on the time, the efficiency. We can see for our method, the difference is not so high. If there's no polarization, it is 50 seconds, and we have MPI thread 3 seconds. There's some difference, but not so high. Anyway, if we also have do an expand experiment by using 500,000 and 1 million treated data. This is a bigger number. Actually, we also can move it to even more. For example, few million data, this move to gigabyte or even bigger size of data. Right here, we can see the difference between no polarization and polarization. We can see if for 1 million data, 1 million treat at the fusion of remote sensing and this treats, it reads 1200 seconds if there's no polarization. With MPI threads, we only need around 1 minute, is about 1 to 2 minutes. This is a huge difference. So that means if we really want to have real-time or near real-time implementation for the Earth-observed applications, this is a good solution to maintain or to have the efficiency. Next page. Thanks. So here we are going to give a conclude of some future challenges, because the focus on this is the focus of this talk is on the future of remote sensing and social media data, because they have different font structures, the fusion different domains. All the two have distributed polarization, and we also need to create or to develop new techniques for the fusion. Then we can focus on polarization. As we here in this talk, we focus on the text, the treated data, but we also can use media, other media data, for example, content, picture, video, positions. This we believe is the future for this multiple fusion for remote sensing and other type of data. Also, as Jun mentioned in the very beginning, remote sensing data is, by definition, is a big data problem. So here although we involve 1 million, in the experiment we use 1 million treated and remote sensing data, but it's compared with the scale of remote sensing is still quite small. For real Earth observations, we are going to have even higher and large volume. This needed to be considered. The final one is the GE platform. It's very powerful. It's a very powerful platform and provides us a lot of potential and opportunities to process the remotely sensed big data problems.